Today we're going to work on the steps and rules for taking fractions and dividing them. We're going to take whole numbers and divide them by fractions, fractions divided by whole numbers, and then mixed numbers divided by other mixed numbers and fractions. When we talk about dividing fractions and mixed numbers, it's good to know that we're actually never going to do any division until our very last step when we convert an improper fraction back into a mixed number if necessary. What we're trying to do is we're trying to get our problem set back up to a multiplication of fractions problem. In order to do that, there's one important piece of vocabulary that we need to be really good at, and it's this concept of a reciprocal. When we talk about a reciprocal, what we want to think of is just two fractions that when we multiply them together and get a product, that it's equal to 1. And they are the inverse of each other. They're not the opposite of each other. We're not talking about 1/2 and its opposite, which is -1/2. We're talking about the reciprocal. A good, easy term to think of when we think of a reciprocal is the flip. So when we look at 2/3, the flip of 2/3 is 3/2. And if we were to multiply across, we would see that 2 times 3 is 6 and 3 times 2 is 6, therefore giving us a product of 1. If I take the whole number of 8 and I put it over 1, like we can do with any whole number, the reciprocal of 8/1 would be 1/8. Therefore, 8 times 1 is 8, and 1 times 8 is 8, giving us a product of 1. So we're going to be dealing with the reciprocal when we talk about the steps involved in taking a division problem and converting it into a multiplication problem. So here we go. When we want to divide fractions and mixed numbers, the first thing we need to do is keep the first fraction the same. So the first fraction, as I'm reading from left to right like a sentence, will always stay the same. I will never change it. The next thing I want to do is I want to change the division symbol to a multiplication symbol. So this would be 7/8 times, and then the third step would be flip the second fraction to its reciprocal, to its flip, the inverse of it. So the original fraction is 3/1. The flip of it would be 1/3. Now the neat thing is once I'm back to a multiplication problem, I'm already familiar with these steps because we've worked on them before. So I have choices. I can go straight across, I can cross cancel, or I could use prime factorization to do the multiplication part of the problem. And then our last step is always the same, simplify if possible. So I'm going to go straight across here. 7 times 1 is 7. 8 times 3 is 24. I ask myself if they have any common factors that I can divide both by, and they do not. So I am finished. So I took a division problem, I converted it back into a multiplication problem, and solved for it. In my second example here, I've got a fraction and a fraction. I've got 5/14 divided by 4/7. What I want to do is follow my steps. First fraction stays the same, so I rewrite 5/14. I change my division symbol to a multiplication symbol, and I multiply it by the reciprocal, by the inverse of 4/7. 4/7, if I flip it, would become 7/4. Now I have choices. I can go straight across, or I can cross cancel to try to simplify it before I do any multiplication. In this case, I'm going to try to cross cancel. I look at 5 and 4. They don't have any common factors that I can divide both by, so I'm going to look at 7 and 14, and they do. I can divide both of these by 7. I take 7 and divide it by 7, and I get 1. 14 divided by 7, and I get 2. Now I go straight across. 5 times 1 is 5. 2 times 4 is 8. I cannot reduce that anymore, so I'm finished. 5/8. So 5/14 divided by 4/7 is actually equal to 5/8. Now, I've got one step added when I'm talking mixed numbers. It's the same step that was added before when we multiplied mixed numbers as well. I cannot leave them mixed numbers. I have to convert them to improper fractions before I do any kind of movement with my keep it, change it, and flip it. So I'm going to multiply my denominator, my whole number. 8 times 1 is 8, plus 3 is 11, and I always keep the denominator, divided by 4 times 8 is 32, plus 1 is 33. And now I've got a division problem set up using the improper fractions, which is what I want. Now I can go to my steps for division. And I'm going to keep it, change it, and flip it. Keep the first fraction, 11 divided by 8. Division changes to multiplication, and the flip of 33 over 8, its reciprocal would be 8 over 33. I like this problem because anytime I look diagonally and see the same numbers, I can always cross them out and make them ones, because 8 over 8 is the same as 1 over 1. Here I look diagonally and I can see that 11 and 33 have a common factor of 11. So I'm going to divide both by 11. 11 divided by 11 is 1. 33 divided by 11 is 3. Now I go straight across. 1 times 1 is 1. 3 times 1 is 3. And my final answer is 1/3. Last example here. Before I can do anything, I've got to convert these to improper fractions. I know I'm going to keep my denominators of 3 and 4. Bring down my division symbol. 4 times 3 is 12. Plus 1 is 13. So 4 and 1/3 is the same as 13 over 3. 4 times 3 is 12. Plus 1 is 13 over 4. And now I have a division problem set up with 13 over 3 divided by 13 over 4. So I'm going to keep it, change it, flip it. First fraction always stays the same. Division symbol changes to multiplication, and the reciprocal of 13 over 4 is 4 over 13. When I look diagonally here, I like that I see that they are the same number, so 13 over 13 is the same as 1 over 1. So 4 times 1 is 4. 3 times 1 is 3. And now I have a situation where I still have an improper fraction. So my last step would be to simplify it and convert it back into a mixed number using division. 4 divided by 3. 3 goes into 4 one time. 3 times 1 is 3. Minus 3 and I get 1. I read it like I'm going around on a clock from the 12 to the 6 to the 9. So my final answer is 1 and 1/3. 1 and 1/3. Most important thing as we recap is that when I'm dividing fractions, all I'm really doing is converting them back into a multiplication problem, whether it's a fraction and a fraction, a whole number with a fraction, or mixed numbers involved. And then I'm following my steps for multiplying fractions, multiplying mixed numbers.